Hello, welcome to my YouTube channel. Today we'll talk about differentiation. Of course, the subtopic is first principle. How to differentiate using first principle. Now, if we have a function y equals to x raised to power n, if we differentiate this, we're supposed to have dy over dx to be nx n minus 1. This is the general formula for differentiation. Now, let's take for example, if I'm asked to differentiate y equals to 1 over x squared. Now, using this formula, I can write y equals to 1 over x squared as y equals to x raised to power minus 2. This is in indices form, right? X raised to power minus 2. Now, if you compare this to this, you discover that your n is equals to minus 2. My n is minus 2. Then, if I differentiate dy over dx, I should have, where I have my n, I'll have minus 2 x raised to power minus 2 minus 1. And this will give me dy over dx to be equals to minus 2 x raised to power minus 3. Okay, this is the differentiation using the formula, the general formula for differentiation. Now I want to teach you how to use first principle to differentiate this. Now, using first principle to differentiate this, I'm supposed to have the same answer. Now, using first principle, I should have my function f of x, which is the same thing as y equals to my function f of x, is equals to f of x plus change in x minus f of x over change in x. Now, if I have this, and from y equals to 1 over x squared, means that my y is the same thing as my f of x. So I can as well say that f of x is equals to 1 over x squared. Now that means from the formula I have f of x already as 1 over x squared. So I need to find f of x plus change in x. Now how do I find f of x plus change in x? So I have, I'm looking for f of x plus change in x. So I have f of x plus change in x, which will be 1 over x plus change in x all squared. Because since I'm looking for f of x plus change in x, so anywhere I see my x, I'll put my x plus change in x, then I'll square it. Okay, that will give me that. So when I expand this, I should have 1 over x squared plus 2x change in x plus change in x all squared. So this is my f of x plus change in x. So I'll go back to my formula and impute this. So I have 1 over x squared plus 2x change in x plus change in x all squared minus my f of x is 1 over x squared all over change in x. So I'll look for my LCM here, and that will give me my LCM will give me x squared plus 2x change in x plus change in x all squared. So if I divide this, the denominator, that's my LCM, with this, I'm left with x squared. So x squared times 1, that will give me x squared, minus, if I divide this with this, I'm left with the whole of this. So that's my times 1, I'll have x squared plus 2x dx plus change in x all squared. So the next thing to do is to open the bracket here. Now let's keep this in mind that this is our answer for the using the general formula, minus 2x raised to power minus 3. So we're supposed to have the same thing. So I expand that, I have x squared minus x squared minus 2x change in x minus change in x all squared all over x squared plus 2x change in x plus change in x all squared. But I think we're forgetting something. This is all over change in x. So we should have all over change in x here. So I can just put it here, all over change in x. Now, this and this can go, so I'm left with minus 2x change in x minus change in x all squared over, of course this is divided by change in x over 1. So once I change it 2 times, it becomes 1 over change in x. So this change in x will multiply this. So I have something like this, x squared plus 2x change in x plus change in x squared, then times my change in x. Okay, now from here I can reduce my change in x with this and this, then I'll have minus 2x minus change in x all over. I can decide to open this, so I have x raised to power 4 plus 2x cubed change in x plus x squared change in x all squared. Now from here we'll take the limit as change in x approaches 0. Take the limit as change in x approaches 0. So I'll say limit change in x approaches 0. That means all the change in x becomes what? 0. So I'll be left with minus 2x minus 0 over x raised to power 4 plus this becomes 0, 0 times this will have 0, this becomes 0, 0 times this will have 0. So I'm left with minus 2x over x raised to power 4. And when I cancel out, I'm left with minus 2 over x raised to power 3 divided by dx. Now this is also, I can express this as minus 2x raised to power minus 3. And this is the same thing with the first one we did. If you like this video, please subscribe to my YouTube channel, Calculus 360, share, like, and comment. Thank you.